Good morning, folks. There were some questions in class this week when we went over indirect proofs. Since a few of you were gone, I thought it'd be good to make a little video going over some of the difficult homework questions that I reviewed in class. First, a bit of introduction with indirect proofs, just by way of review. As you probably remember, direct proofs are going to start from given information. You'll start the proof with a few givens, and then you'll reason from definitions or postulates or previous theorems to lead to a certain conclusion, that which you're asked to prove. Indirect proofs, however, are going to show that any alternatives to the conclusion that you're asked to prove, the alternatives are false. And since the alternatives are false, the original statement must be true. So it's a different way of going about the reasoning through it. In most indirect proofs, the statement and its negation are the only possibilities. If there are other possibilities, then the indirect proof is not a watertight method of work. But you can assume in the problems that we'll be getting in our homework that it will be. You might remember from chapter 2, I believe, when we looked at reasoning a conditional, we'll be saying if P, then Q. The logical equivalent of a conditional is the contrapositive. So if there's no Q, then there's also no P. The indirect proof is going to be dependent upon that kind of reasoning. And now we're going to go over and work at a couple of the homework problems. This is number 27 from page 231 in your geometry textbook. So if the square of an integer, n squared, is odd, then n is odd. Now our first step when doing an indirect, our format for indirect proof is going to be statement 1, statement 2, and then you have statement 3. You're going to have 3 statements you're going to make. In your first statement, you're going to write the contrapositive of the original conditional. So 27 is in the form of a conditional, if P, then Q. So P is if the square of an integer, n squared, is odd. Q is going to be, then n is odd. So our first statement is going to be the contrapositive. If there's no Q, if Q is negated, then P is also negated. So our first statement is going to be, we're going to assume that n is even. So my first statement is simply the contrapositive of the original conditional. Now, in the second statement, I'm going to take that reasoning that I've often done in 2-column proofs or paragraph proofs. I'm going to apply that same reasoning to this assumption I've made. So, assume n is even. Well, an even number is simply going to be, let's take n. We're going to assume n is even. Any number times 2 will be an even number. So I'm going to say a number, k, times 2 will give me an even number. So assume that n is 2k, and I'm going to assume then also that k is an element of the integers. And then I can also say that n squared, that will be the same as 2k squared, which equals 4k squared. This 4k squared is going to be even because it's divisible by 2. So I've followed my reasoning in my second step. Now in my third step, I'm going to start with a but statement. But n is odd according to my original problem, but n is odd. Therefore, n must be odd. So my first statement, I take the contrapositive. Second statement, I follow reasoning to a point where I end up contradicting the given. And then my third statement, I show that contradiction. Let's take a look at 29. In 29, we also have to work with an inequality instead of an equal statement, which is something that we're not used to doing so much in this up to this point in class. So we're given that a plus b is greater than 100. We have to prove that either a or b is greater than 50. So again, We have three statements we're gonna make. We're gonna work in that format. In statement 1, we're going to assume, again, we've got if P then Q. So if A plus B is greater than 100, we're going to prove that either A or B is greater than 50. So we're going to have to take, and we negate Q, which will also negate P. So we're going to assume that neither A nor B is greater than 50. Now, if neither A nor B is greater than 50, then we can conclude that A is equal to or greater than 50, and B is less than or equal to 50. And then we can sum these in an inequality statement. A plus B will be less than or equal to 100. So I'm following the reasoning of the contrapositive I make in statement 1. So in statement 2, look what I've ended up with. I've ended up with a statement that contradicts the given, because the given says A plus B is greater than 100. But if I follow the reasoning in my assumption of statement 1, I follow that reasoning in statement 2, I end up contradicting it because A plus B is less than or equal to 100 in this reasoning. So statement 3 says, but A plus B, like I said, is greater than 100. That's my given. And remember, the given's like the gospel. You cannot contradict the given. Either the given's false or the result of statement 2 is false. And in that case, only one of them is true, and the given will always be the one that you go with. If A plus B is greater than 100, therefore, either A is greater than 50 or B is greater than 50. So I end up going back and I've proven the second statement of the original conditional. That's how that works. Now I'm going to work through 3 examples. This is number 31 on page 231. We are given that the measure of angle 1 is not equal to the measure of angle 3. And I have to prove that line M is not parallel to line N. So I'm going to start out again in the form of my first statement. I have to contradict what I'm asked to contradict what I'm asked to prove. I'm going to assume that line M is parallel to line N. So I'm taking the contrapositive. I'm assuming that. Well, if these two lines are parallel, then angle 1 will be congruent to angle 2 because they are alternate exterior angles. And then I can take another statement. The measure of angle 1 will be equal to the measure of angle 2 because of the definition of congruent angles. So now I've reasoned to a point where I'm contradicting one of my givens. So I say, but the measure of angle 1 does not equal the measure of angle 3. That's my given. Therefore, lines M and N can't be parallel. These are my 3 statements I work with. And notice in statement 2, I can either do a 2-column proof in statement 2 if needed, or I can do a paragraph proof. It doesn't have to be, if it's a paragraph proof, it doesn't have to be in as great a detail, perhaps it's the 2-column proof. But I have to follow the reasoning of statement 1 to a point where I'm contradicting one of the givens. And once I show that there's a contradiction, that means that that what I'm asked to prove, in this case, line M and N are not parallel. Once I've reasoned to a contradiction, it shows that the given is true, and my assumption's false. Let's move over to question 32. I am given a scalene triangle ABC with altitude segment BD, and I want to prove that BD isn't a median of the triangle. So my first statement, I'm just going to go about assuming the opposite of what I'm asked to prove. So I'm going to assume that BD is a median. Well, if segment BD is a median, just kind of follow this out. If segment BD is a median, and here I can kind of follow a two-column proof, statement and reason. If statement BD is a median, then D is a midpoint, because that's based upon the definition of what a median is. If D is a midpoint, then I can say that segment AD is congruent with segment DC, right? Because the definition of, let me think about that, would be the definition of midpoint. So I would go like this, and then say, I could say that BD is congruent to BD because of the reflexive property. And before you know it, I'm going to be reasoning, I can say that the triangle ABD and triangle ABD and CBD are right triangles. I should have made a statement that angle D is a right angle. Once I've done that, I can say that triangle ABD and triangle CBD are congruent because of leg-leg. And if they're congruent, then segment AB and BC are congruent because of CPCTC, and that would make this triangle isosceles. I'll put statement 3 over here. But triangle ABC is scaling, therefore segment BD can't be a median. This is a really good example of an indirect proof. I assume that BD is a median, so I'm assuming the opposite of the Q in my original conditional. I use reasoning to make conclusions about this triangle based upon my false assumption, and then I end up reasoning to a point that I say that triangle ABC rather, is isosceles. I reason to that conclusion based upon this assumption, and then in my third statement, here we have it. Whoops. In my third statement, I see that my conclusion in statement 2 contradicts a given, therefore my original assumption has to be wrong. This is just a way, another example of an indirect proof. Now, we'll use 33 as our last example here. We're given that angle A is congruent to angle C. I better move this out. To angle C. And AD, I have a length, not a segment. Length AD is not equal to length DC. So I have to prove that the measure of angle 1 is not equal to the measure of angle 2. So we're going to assume, in our statement 1, we're going to assume the opposite of what I'm asked to prove. I'm going to assume that the measure of angle 1 is equal to the measure of angle 2. Well, if the measure of angle 1 is equal to the measure of angle 2, then I can also say that angle 1 is congruent to angle 2 because of the definition of congruent statements. I'm going to give this more as a paragraph proof as I'm going to be talking to save a little bit of time instead of having to write everything out. If angle 1 is congruent to angle 2, then that means that we'll be able to show congruence pretty fast. We can also say that because angle A and C are congruent, then we've got an isosceles triangle. I can say that BD is congruent to BD because of the reflexive property. So I can say, to make these statements, angle 1 is congruent to angle 2. That's our assumption. This shows how important correct assumptions are. And I can say that segment AB is congruent to segment BC, and that's because of the converse of the isosceles triangle theorem. And then I can say that BD is congruent to BD because of the reflexive property of congruent segments. And before you know it, I've got side angle side. So I can say side angle side congruence proves that AB, right, proves that triangle ABD is congruent to triangle CBD. If these two triangles are congruent, that means that segment AD is congruent to segment DC, which allows me also to say that AD is equal to DC because of CPCTC and the definition of congruent segments. Statement 3 says, but the given says that AD does not equal DC. Right? Therefore, make sure I get this right. This is 33, yeah. Therefore, the measure of angle 1 is not equal to the measure of angle 2. So my third statement shows that I'm contradicting the given, and what I'm originally asked to prove, I prove it indirectly. I trust this will help a little bit. Now that I've gone over the proofs, maybe you can try to do them on your own. We'll cover some more questions in class if needed. Good luck, folks, and look forward to seeing you Monday. Hope everybody gets feeling better.